subtracting. Yeah, we need to add and subtract those polynomial fractions. Now remember, the most important thing when you add or subtract fractions, you need a what? A common denominator. Now with numbers, a lot of you are real good getting those common denominators, but now we're talking variables. So we're going to have to do it with variables and numbers, so we'll feel the power as we do it here. So let's go to the graphic and we'll look at how to get that most important common denominator. All right, and it's also in some cases called the least common multiple if you're just given the plain old numbers, and in fractional form they call it the LCD, or least common denominator. So notice to get it here, and write this down and keep your notebooks organized there, keep these notes going on these graphics. Factor denominators if necessary, and break all numbers into prime factors, okay, or prime numbers. We're going to talk about prime numbers. Multiply each factor the greatest number of times that it appears in any one factorization. All right, so let's go to the examples here. Let's talk about prime numbers first. I saw this on one of the game shows the other day. They were asking, what is the smallest prime number? And it was worth some bucks on the show. And everyone said 1, and I think even the audience said 1 on the smallest prime number, but the smallest prime number is 2. Because notice the definition of prime numbers here. Prime numbers have two factors, 1 and itself. So by this definition, why isn't 1 prime? Well, 1 only has how many factors? 1. So 1 only has 1 factor, so 2 is really the smallest prime number. So if you're ever on a game show and you got big bucks at stake, 2. Okay, other prime numbers I started writing out here: 3, 5, 7, 11, 13, 17, 19, 23, and so on. There is no largest prime, so we could go on until infinity. There are numbers in the millions, billions, zillions that are prime here. All right, so prime numbers only have 2 factors, 1 and itself. All right, so what we want to do now with that is find the LCM, or if these were fractions, we would call it the LCD. I could make these numbers fractional form, of these 3 things. Now think if these were fractions, could you guys give me a common denominator out there of 28, 42, and 60? Oh, yeah, I don't know. That would be a hard common denominator to get, to put those fractions together if they were fractions, right? But since they're numbers, they call it least common multiple. So numbers that aren't prime are called composite. All right, so any number that's composite can be broken into prime. So I'm going to go ahead and I'm going to take 28 here and I'm going to prime it. Okay, which of those prime numbers that we had listed in the last thing will go into 28? Well, since it's even, that smallest prime number of 2 will go into it. So 2 goes into 28 14 times. Okay, is 14 prime? No, because 2 goes into that since it's even. How many times? 7. So when you get to the top number, now this is what's called the prime factorization of 28, which is 2 times 2 times 7. Now, Young, how do I know that's right? Well, multiply them together, you get 28. All these numbers are prime. Yeah. All right, we're going to do the same thing with 42. Let's get prime out of there. All right, so we'll come over here on the side. What prime number goes into 42? Now, some of you might say 2 out there. Some of you might say 7. You'll get to the same spot. Does not matter. I'm going to go ahead and cut it in half and say 2 goes into it 21 times. All right, is 21 prime? No. 3 goes into it, or you could say 7 goes into it, and you'll get the other one. All right, so the prime factors of 42 is 2 times 3 times 7. And you can multiply that back and it'll check. And same thing for 60. Let's go ahead and prime it here, like you do your lawnmower. You ever go out there? I know this is summertime when I'm taping this, and we're mowing that yard all the time. I'm out there priming that lawnmower, so now I'm priming these numbers in here in the studio. I just can't get away from priming things. So anyway, 2 goes into 60 30 times. 30 is not prime. 2 goes into it 15. And then we end up with 15, 3 goes into it 5 times. So on 60, I end up with 2 times 2 times 3 times 5. So once you get all numbers broken down into primes, it's very easy to find the common denominator, or the least common multiple of the numbers. And here's how you do it. We looked at that graphic there. The graphic said, break all numbers into prime factors and multiply each factor the greatest number of times that it appears in any one factorization. So in other words, which one of these has the most 2's in it? Well, I see 2 2's here, 1 here, and 2 here. So the most 2's in any of these would be 2. Now, a lot of people say, but Young, there's like 2 here, 1 here, and 2 here, so there should be 5. No, you just take the most of each one in any of the given ones. All right, now what else do we need? The most 3s. Well, they're tied at 1 in these two, so the most 3s would be 1. The most 5s? 1. The most 7s in any of these? 1. So when you put all of those in your LCM or LCD pot, that always, always, always gives you the smallest denominator that all 3 of these will go into. Isn't that neat? So when you multiply these together, 2 times 2 is 4, times 3 is 12, times 5 is 60, times 7 is 420. Right, so the least common multiple of 28, 42, and 60 would be 420. Now think if you multiplied those numbers together, all together, I mean, you could get some other common multiples. I mean, you could get numbers out there in the thousands or maybe even larger than that. But let's think about it. If we want to put these fractions together, we want to get that L. I like the L part of that LCM or LCD. It means the least. So 420 is the least, the smallest number that these 3 will go into. And you'll notice if you multiply something by 28, you'll get to here. 42 times 10 will get to here. 60 times 7 will get to here. So all 3 of these will go into there evenly, so you know you're done. All right, in closing, now that you have the algebra concepts within your grasp, you know what to do. Math is like a bank. What you put in or deposit, you can withdraw come test time. What you don't put in, you won't get out. Think about it. Take care. We'll see you next time.